Started. Welcome to the 2024 winter, spring, or February, April ENP study group through On Scene First. This is technically week 13 or session 13. Today we're going to be talking about signaling and information systems. And just to disclose, got way behind on this particular study session, but it happens. I updated all of my presentations, added a bunch more stuff, and it took a little longer than expected. But over the next week, you will get additional recorded sessions sent to the Google group. So with that, I will just pop on over to the next slide to give my kind of disclaimer information. This study group session went from October 6th to January 19th, which is today. Today is the last live recorded session, last live session. And a few more sessions will be recorded, and you will have those in your possession within the next week. I'm going to be recording most of them this weekend, and then getting them uploaded as soon as possible. And that will also include the practice exam that is being cleaned up and edited as we speak. So as soon as that is back in my possession, it will be sent off to all of you. And I will send it with a little recording because I have a disclaimer with the practice exams as well. But just know that it's going to be a lot of questions on that practice exam. And while I'm not 100% sure if that is all the material that's going to be on it, it's based on the materials that we have been studying over the last several weeks. And it is the best I can do, not knowing what is going to be on the exam. So if there are things that pop up that are not known to you, then I recommend looking at that subject a little bit further. If it is after January 19th and you have stumbled upon this video and you want access to the recorded materials, the videos, the PDFs, the practice exams, any additional information that I've provided, please go ahead and scan that QR code, head on over to onscenefirst.com/training/study ENP. And the website is updated for you to request access to the recorded materials, as well as registering for the next live study group. That link is live. So if you're not planning on taking the exam until the summer or fall and you want to rejoin for the next live session, you can register. That is live on the website now. So there's that. As mentioned, we had partnered with Nina Ontario. We recorded a session with them last week. So week 12 is the Canadian material that you guys need to check out. And well, if you're from Canada, they covered that information. Lisa, I think I've registered for the session beginning of March. How can I be sure? If you want to just shoot me an email, teldridge@onscenefirst.com, I can for sure check that out for you. Or you could just head on over to the website and throw your information in again. And if you've already had access, my assistant would let you know. So you should be good. But if you want to shoot me an email, I can let you know if you're registered. Thank you so much to Rapid SOS, our premier study group sponsor. They are going to be the sponsor for the 2024 group as well. So I'm really excited about that. And I appreciate their support as always. And now we will jump into today's topic. But like I said, there's a couple of topics. I'll just let you know what is coming. So the next generation 911 network section is coming. I have updated that. I've added a little bit more. I've accumulated a few more analogies, and I was going to do it today, but I wanted to I have a new kind of diagram I'm going to be using, and that seems to be a heavy topic on the exam. So I always want to put as much as I possibly can into that session, and I just didn't get a chance to get it fully complete. So what you can expect over the next week for recording is going to be the next generation 911 framework, legislation, which is wicked boring. I do have a couple of tips and tricks on how to remember which laws and regulations go with what particular thing and how you should kind of remember it. But there's really no way for me to kind of teach that legislation. So what you'll get is all of the legislation stuff and any additional information that I can give. Otherwise, you're just going to have a copy of that information. And another one of the sessions is the NENA standards information. And on that one, I do have a couple of things that I realized did not get into the presentation where they were supposed to. So I went back and I reviewed some topics that folks had sent me to say, hey, add this to your presentations going forward, because it was on there and I don't remember seeing it. And a couple of those things fell through the cracks. So in the one with the NENA standards, it's going to be titled NENA standards and missing information. So the majority of those sessions are already updated, ready to go. I just have to record them. So that's what you can expect in the next week. So here we go. So going back to some of the technical stuff, I'm sure many of you have heard the reference CAMA or CAMA trunks. I have mentioned this before in some of the architecture and the beginnings of the 911 system, but CAMA stands for Centralized Automated Message Accounting. Now, one of the things that I do when I prepare for an exam is to try to pick out words that are going to be relevant when it comes to trying to remember what the acronym is. So centralized automated message accounting. When I think of accounting, I'm thinking of numbers and billing and money and things like that. And so what that'll remind me of is that the CAMA processing was initially designed for toll billing purposes. If you remember me saying, way back in the day, we would call my Aunt Linda after 7 o'clock because we wouldn't get charged for long distance calling. Well, when we get into LADAs and, in your calling, you're in your local calling area, whether it's in your area, out of your area, they had to have a way to keep track of when to charge you for long distance calls. So CAMA was originally created for that. And I'm pretty sure you're going to see a question on that as well. It is an arrangement that records detailed call information at a centralized location other than the central office. CAMA uses a switch at the centralized locations to serve as a hub for central offices to collect the ANI information. So it's going to grab that phone number. It's going to register the call duration. And then it's going to also assist in routing the call if it is outside of that service area. CAMA plays a pivotal role in the effective functioning of 911 emergency services by ensuring accurate call taking, facilitating billing processes, supporting resource allocation, and contributing to the overall performance monitoring and improvement efforts. So needing that information for quality assurance purposes, etc. It is a critical component for maintaining emergency communication systems integrity, efficiency, and accountability. When you think about it, when we go back to things such as call processing times, call handling times, etc., that information has to come from somewhere, and it's going to be captured here on your CAMA trunks. If you want more information on this particular process, this is also recommended as a review in the study guide. Just know when you go back to, when you copy that URL or click on that URL, it's going to bring you to an archived version of this information. I have not successfully been able to locate an updated version. So the archived version The information doesn't change. It's just archived. I'm assuming they're working on a newer version, but for whatever reason, this particular one has been archived and I haven't been able to find a newer version. CAMA is a type of in-band analog transmission protocol that transmits telephone numbers via multi-frequency encoding. And that multi-frequency thing, we'll talk about that in just a little bit. It has to do with simultaneous tones when it comes to the dialing process. If you have a question on CAMA, just know that we've been moving kind of away from the CAMA, going more towards SIP trunking, etc., which we'll talk about. But analog is always going to be the older version of whatever it is that we're doing. We move towards a more digital environment these days. So if the word analog is there, then chances are it's going to identify the CAMA as the answer. They're used between the originating end office and the selective router, and between the selective router and the PSAP. So lots of places where this information can be captured for different purposes, actually. So again, I must have duplicated the slides, but the multi-frequency signaling, again, it is making reference to this particular document. So I would peruse that if I were you. And just know, again, it is archived. But let's talk for a minute about multi-frequency signaling. It is a type of in-band signaling used on analog interfaces and 911 trunks. I'm going to read the definition and then I'm going to break it down in simple terms. MF is a type of address signaling in which the 10 decimal digits, 5 auxiliary signals, are each represented by selecting a pair of frequencies out of the following groups. Now, I don't think you need to know which groups are what or what different tones make what. But when you think of dialing a telephone and you press one of the buttons, just know that if you're looking at the dialing pad, right? I guess I should have put a picture of that. So you're looking at the dialing pad that 1, 2, 3, 4, 5, 6, 7, 8, 9, asterisk, 0, pound sign, hashtag, something Thorpe. I forget what it's actually called, but the way those numbers are organized on the touch tone pad, when the numbers go down, I'll start with across. When the numbers go across, it has one tone. When they come down, it has another tone. And so what happens is when you press one of those buttons, it's going to put two of those tones together. And when it puts two of those tones together, then it basically starts to become an address of where that call is going to go. So when it's referring to multi-frequency, as you can see here, when you look at the 1 on the left side and the 0 on the top, so it's the way the tones are put together. You're not going to get questioned on that. Just know that that's what they're meaning by multi-frequency. Dual tone multi-frequency is taking it a step further. It's moving away from just a simple multi-frequency to a more specific. And what this does is, so where the multi-frequency was used for just dialing, the dual tone multi-frequency allows us to use during call tone functionality. So press 1 to get to the police chief's office, press 2 for dispatch. When you press that button, that is what is going to be called touch tone dialing, and that allows us to the dual tone multi-frequency is more advanced, and it is what allows us to select from menus, etc. The link that you see there and the screenshot is an older video. I'm talking wicked old, but it explains multi-frequency and dual tone multi-frequency pretty specifically, and how it moved from the switching error to where we are today. So when we used our rotary phones and it was like that tick, 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 that was that switching process where the little level of switching techniques go. If it moves here, here, and here, it's going to be this number, etc. So good video for you to check out to have a little bit further explanation there. Is MF and DTMF the same thing? The answer is no. It sounds similar, but here's where your differences lie. Both use a combination of two tones to represent a number or character. However, the tones differ, and MF tones are control signals within the network. And then DTMF tones are signals from the user to the network. So the MF tones, like I said, they are within the network. They're recognized right out of the gate. It's kind of automatic. It has nothing to do with the user preference. And DTMF tones are signals from the user to the network. So that's in the call, pressing 1 for this, pressing 2 for that, etc. In summary, while MF and DTMF tones involve multiple audio frequencies for signaling, DTMF has become the more prevalent and standardized method in modern telephony. I always say telephony, due to its simplicity, ease of recognition, and compatibility across most systems. So, not sure how you can remember that, but there you go. Next section, intelligent networks. So what an intelligent network is, it refers to telecommunications networks that provide value-added services such as call routing, call forwarding, and personalized services. These networks use advanced software and protocols to offer a more dynamic and customized features. And we'll give you some examples of that. So, Internet protocol, IP address. I'm sure you guys have heard this a million times. Maybe you know what it is, maybe you don't. First, it is a method used to transmit data over the internet. So when you refer to an IP address, it's going to be identifiable and it's going to assist in transmitting information over the internet. It is a communication standard that enables computers to route communication traffic from one network to another as needed. And it is scalable and extensible, which allows for growth and change over time. So how we move towards the ESI net and next generation 911, we're doing that over internet-based protocol systems. Integrated service digital networks. Into another intelligent work, say whatever. Integrated service digital network. Communication standards that use digital transmission to make phone calls, video calls, and transmit data, and other network services over circuits on the traditional PSTN public switch telephone network. That definition in and of itself should remind you of the picture that you see down there in the bottom right-hand corner. Today, integrated service digital networks have been replaced by broadband internet access connections like DSL, WAN, and cable modems. It is still used as a backup when the main system fails. The ISDN, Integrated Service Digital Network, was between the analog dial-up and our digital DSL. So I just wanted to share this. Why? Because it's a piece of nostalgia and I just thought it was cool. This is Integrated Service Digital Network at its finest. Hopefully you were able to hear that. If someone could let me know if you could actually hear it, because I'm not sure if the way my system is set up, right? Tell me, did that like not bring you back? Remember when you had to like get off the phone to use the interweb? Crazy. And it took forever. Intelligent networks, there's different levels, different solutions. I do know that signal system number 7 is a question that you will find on the exam. It's also called SS7. It's basically the dominant protocol used to control the PSTN. It assists in call routing, number portability, caller ID, mobile SMS, and more things are handled by SS7. It's where we are today. It just sounds much more advanced. I don't know. It reminds me of the number 5 alive guy in Short Circuit. I don't know why, but it's just definitely more advanced than what we had dealt with in the past. So this type of signaling is, it basically is removed from the voice channel and put on a separate data network. So as we're moving forward in our next generation 911 world, we need to start delivering more additional data, right? So the signaling is actually removed from the voice only channel, and now it's going to be moved on to something that is more robust. It is an out-of-band signaling system used to provide basic routing information, call setup, and other call termination functions. Now, what you're going to see is that it's very similar to SIP, Session Initiated Protocol. It's all part of each other. Signaling system number 7 is a common version of channel signaling. And then frame relay. So in our advancements in technology, in the 911 I don't want to say in our data world, but in our computer-based network world, the pieces of information and data that move from one place to another are called packets. They're called packets of data. And frame relay is a packet switching telecommunication service designed for cost-efficient data transmission for intermittent traffic between local area networks and between endpoints in wide area networks. So basically, it's getting data to go from one place to the other. And there's a reason why I put puzzle pieces here, because basically that's what happens. If I have a bunch of data that it needs to go from one place to the other, I'm going to think of Mike TV and Willy Wonka, right? So here he's all put together, and then he's going to go up in the air, and he's going to go over, and he's going to be broken up into a bunch of little pieces, like the puzzle pieces that you see there. And then it's going to go overhead very quickly, get to the other side of the room, and then he's going to be put back together in a puzzle piece. Well, he just happens to come back smaller, but I digress. That's irrelevant to this. The process of the packets of information being broken up and sent through the system to be put back together later is what is considered frame relay. So I'm going to give you 2 analogies to remember this by. So when we think of packet switching in simple terms, basically this is just kind of an analogy to think of what packet switching technology is. So A writes a relatively long letter to B, but B's mail slot is only big enough to accept small index cards. To ensure that B gets their letter, A divides the letter into shorter, smaller sections that are perfectly sized to fit through B's mailbox, and delivers these cards to B. B can then put them together in the right order to make sure that the entire message is readable. So that's what packet switching is. It takes all of this information and data, cuts them up into little tiny packets or puzzle pieces, and then it's going to send it on its way. So how does it send it on its way? This is how it navigates through the system. So the 911 call gets placed, and it has one of two choices. It can either take the path that all of it's together and it's going in the same way, same direction as all the other data is going, or it can choose to select a much quicker super highway that is going to parse out the pieces, pick a lane that piece of information needs to go into, and then it's going to get there much quicker. Once it gets to the other side, it's going to then put those pieces back together and all the information is ready to go. So hopefully that explains frame relay. And then if not, if this one doesn't, then this one will. Imagine, if you will, a relay race, right? So what happens in a relay race? So if this was a traditional transferring of data, think of it as a marathon, right? When we start out, everybody's clumped together. It's much slower. You might have some folks that get tripped, they fall down. Not all the information gets to where it needs to go. So what we prefer to do is have a relay, meaning instead of all of the data being clumped up and moving forward at the same speed in the same lane, which is going to mess some things up, we're going to separate it into each individual lane. So just like a relay race, they're going to be in their own lane. They may get there a few minutes before, a few minutes of seconds, actually, a few seconds later, but at the end, they're all put together. Everybody's cheering. And we got to the end of the relay. So when you think of frame relay, think of it as a packet switching technology where little tiny packets of data are separated into their own lanes. They take the fastest way to get to the PSAP, and then they all get put together again. So hopefully that helps. Asynchronous transfer mode, ATM, not the way that we think of an ATM. But think of this as a high-speed conveyor belt for data. It moves fixed size packets efficiently, ensuring speedy and reliable delivery of different types of information throughout the network. So if you think about, I don't know, if you watch on Discovery Channel when they show all kinds of how they make this or how this is made, and they show things going down different conveyor belts and where they need to go. Think of ATM, asynchronous transfer mode. It's transferring that information to the place where it's supposed to go quickly, but each box is a different size. It's labeled differently. And then eventually it's going to end up in the lane that it belongs in. Multi-protocol label switching, MPLS, is a type of data carrying technique for high performance telecommunication networks that directs data from one network node to the next based on short path labels rather than long network addresses, avoiding complex lookups in the routing table. So just like you saw in that previous picture, instead of having this long drawn out address, which could be an IP address, etc., it's just going to say video, data, voice. And it's not going to technically say that, but it's going to be labeled in a way that the information can be parsed out, put where it's supposed to, and get to where it needs to. In other words, or Tracy's words, I want you to think of it as an HOV lane. So when I try to think of Analogies. This one I'm thinking of a high speed lane, an HOV lane, right? So first, MPLS, think of it as virtual fast lanes, the HOV lane. There's labeling for efficiency, which for the HOV lane, it's the signs with the rules and the directions. So it basically tells you have to have 2 more people. It could be between this time and that time. It optimizes the routing. And how does it optimize the routing? Knowing in advance that the HOV lane is going to be open between 6 a.m. and 8 a.m. and then again in the afternoon from 3 to 6 o'clock. Knowing in advance where that information is going to go. Traffic management. I refer to that as the state trooper who is at the entrance, basically telling people, yep, you can go in. That's great. All right, here you go. And if you pull in and you don't have 2 people, he's gonna tell you to pull over and you're screwed. It is flexible and scalable. So when I don't know what your HOV lanes look like, but I'm thinking of Boston, Massachusetts. One of the things that we have that is consistent with our HOV lane is that in the morning it goes into Boston, in the afternoon it comes out of Boston. And you would think that it would just be a simple, oh, hey, let the cars going this way get in and let the cars go this way coming out. And that's not the case. It's actually a big, huge machine that moves these big concrete barriers. It goes like this to shift the lane onto the other side of the highway. So basically, it's flexible and it's scalable to be able to accommodate when the heaviest traffic is, and then secure pathways going back to the state trooper has that security, and it's going to be able to know whether or not that information belongs there or it doesn't. So hopefully that helps. Session initiated protocol, SIP. This is a term that if you are in 911, you should have been hearing for quite some time now. This is where we are moving towards. It is simply put, it's a method for establishing multimedia sessions over the internet. So it's a digital introduction. Hi, it's me. I'd like to get some information from here to here. Once the conversation is started, it's going to make sure that it's communicating to the right person that's finding each other. It's going to establish the rules. You can only come onto this network if you are in emergency. There's flexible language because we know that today there's so much stuff that is going to be able to be pushed to 911 that it has to have that flexible language to say, oh, this is a picture. This is a text message. This is a video. And then it's going to have the ability to end that chat. And it's being used in more phones today than we've seen in the past. So it is basically like a digital matchmaker that introduces devices, helps them agree on how to communicate, and ensures that the calls and the messages find their way to the right destination in digital conversations. So think about a matchmaker. Okay, so SIP is a matchmaker. If you've ever seen a matchmaker on television or have used one yourself, you know that they don't just come in and say, I'm going to put you with this person. First, you're going to meet them. Hi, this is me. You're going to give them a list of rules and regulations. This is what I'm looking for. This is what I'm hoping to accomplish. They're going to set up the time where you guys are going to engage. Then they're going to get feedback, make sure that this is on the right path. And then they're going to go on their merry way. And hopefully that information continues on moving forward. So there you go for that. For information systems, there's going to be a bunch of little pieces of information in here, but we're going to first start with the SOI, service order input. It is basically a file of completed service order updates that are sent to the database management system, DBMS. You want to know what those acronyms are, by all service providers. All service providers have a DBMS, database management system. Sometimes it's called the 911 extract, and it consists of adds, changes, deletes, unlocks, and migrates. So when you send in a discrepancy report for an address that is incorrect or an ESN number that is incorrect, then the service order input is what that discrepancy report becomes. It's going to get added to the packet of information that is going to be processed. They are usually processed in batches. So the sooner you recognize a situation where something is incorrect, and the sooner you get that to them, the sooner it can be processed. And then the information is processed against the MSAG to create records for the ALI database. So how do some of these error addresses get through to begin with? If it needs to be validated against the MSAG, Master Street Address Guide, it's because people enter them. So when folks enter them, they're not always matched up against the MSAG at that point. It's usually when the 911 call is getting placed. So a test 911 call isn't made when the information is originally entered. I don't think that's scalable or reasonable. So it's usually when the first 911 call comes through and that phone number is parsed out and it's sent to the databases, and then it is coming back with nothing or something that's incorrect. That's the first you're going to see that there's an issue. So once you see there's an issue, you're going to fill out that discrepancy report, send it to the powers that be, and then it becomes an SOI, service order input. In the body of knowledge, under the information system section, there's the word SAG, S-A-G. Now, with that said, I have not been able to find what just SAG stands for, and I'm going to make an assumption. It is for Street Address Guide, not Master Street Address Guide, Street Address Guide. And with that, I had somebody email me after saying that they did find a definition, but they don't remember where they found the definition for just SAG. And this is what was given: a listing of all existing structures within a 911 service area. Whether or not that is what they're looking for here, in full transparency, I don't know. It makes sense because of the topics that we're talking about in this section. But just know that when we talk about a Master Street Address Guide, which we will, it is just that. It's anything with an address. So maybe it's a structure, maybe it's not a structure. I'm going to assume all things with an address in a 911 service area. So take that for what it's worth. And if I'm wrong, I apologize. Now let's talk about the Master Street Address Guide, the MSAG. We know that the MSAG is going away with next generation 911. We just have different technologies that are going to be replacing it. But the MSAG is a listing of all address information within that 911 service area. Typical elements will include the low and high address numbers, street name, pre and post directional, suffixes, communities, states, and the ESN. It's usually managed by the 911 authority, their 911 coordinator. So this is what the MSAG looks like, and it contains that information. So low address, I don't know of a street that would be starting at 100, but basically what it's saying is for this particular street, Main Street, the lowest number is going to be 100. The highest number is going to be 149. Does it contain even and odd? One of the streets in our town the name of it is county road, but we only have the odd numbers. So in this case, it would just say odd. So the number range would be from, 1 county road to 100 county road, but it's only the odd numbers. So if one of those calls should come through to us and it doesn't belong to us, well, then the MSAG is going to need to be updated. So we fill out the discrepancy. It then becomes an SOI, and then it gets batch uploaded, and that fix takes place. And so you can see that information there as well. I know that we touch base on these. I'm going to touch base on them again. I can't remember if I actually had the full definition for them or if I had just made reference to them. So I want to make sure that the actual definition is in a PowerPoint somewhere. And that's the emergency service numbers, ESNs. There are a lot of folks in 911 that do not know what an ESN is, what the purpose of the ESN is, what their ESN number is. And I highly recommend you know what your ESN number is, because when you're reviewing the alley on your screen, which is part of your responsibility, confirming that the ESN is one of those things that you're supposed to be doing. So the ESN is a 3 to 5 digit number representing one or more emergency service zone, which we'll talk about on the next slide. It's stored as a 3 to 5 digit character numeric string in a GIS database. There are 2 types of ESN. One is administrative and one is routing. Administrative, it's stored in the MSAG, and it is returned from an alley query. So when that phone number is parsed out and it's sent to the database and it gets to the MSAG and it gets to where it's supposed to be, it's going to determine based on the address, the street, whatever information is available as to what the ESN number is and where that call is going to go. And then it facilitates dispatching the proper service agency. So when you look at your screen, and I think I did put this on one of my, one of them way back on routing, in Rochester, we have 2 ESN numbers. The reason why we had 2 ESN numbers is because if it was this address, we needed to, if it was one particular address on one side of town versus the other side of town, it would dictate which ALS mutual aid response we would request for that particular address. So if it was on this side of town, we would notify Wareham. And if it was on this side of town, we would notify Freetown. So on your alley screen, you'll see PD, EMS, fire, or FD response. And then it identifies which emergency service agency is going to respond based on that particular location. And then the routing, selective routing of the 911 call is based on that ESN number. So if the ESN number is wrong, based on the MSAG information, then that call can get routed to the wrong agency. So you could be looking at a screen, not know why it made it to you when the address was incorrect. It is humans that enter ESNs. So somebody transposed a number, and that's why you got the call. Knowing that it wasn't your ESN or the address doesn't belong to your ESN, then prompts a discrepancy, which becomes an SOI, which then gets sent in as a batch to be updated. The emergency service zone is a geographical area that represents a unique combination of emergency service agencies, law enforcement, fire, EMS, that is within a specified 911 governing authority's jurisdiction. An ESZ can be represented by an emergency service zone number to identify that ESZ. So when you look inside, you see that yellow. Inside that was where all of those ESN numbers were. And They could be associated with a particular emergency service zone, and that's that red that is outlining it. Your alley records, a result of processing data extracted from the customer service records against the MSAG and the alley database. And again, it's when the phone number, the Annie, is parsed out, separated from the information that came in with the call. It's wrapped in a packet. It's sent on over to the alley database. It's sent over to the MSAG. And hopefully at that point, it's going to bring back additional information, which is going to contribute to the information we get under phase 2 location, especially when it comes to our wireless calling. This database contains the content of the record that is displayed on the 911 equipment when the 911 call is received. And then a record is considered MSAG valid if there are no discrepancies. Selective routing records. These records comprise another database produced as a result of customer service records being processed against the MSAG. So if I moved into my house and I called the phone company, I got a new phone, nobody else lives on this street. Ironically, my driveway is named my way. I didn't name it. It just happened that way because there is no frontage on the main road. So for 911 purposes, we had to name our driveway, or the people who owned the property before us had to name the driveway. So they named it my way. And then when we moved here, we needed to get the communication center to basically sign off and accept this new road. So a lot of times it goes through the building department, et cetera. And that information is checked against the MSAG, because if we just put the phone number in and none of that took place, when I called 911, it wouldn't validate. These records are sent to the selective router database, the SRDB. And basically what happens is it converts the phone number into that ESN, which then directs it to where it's supposed to go and identifies what services are to be responding. The full 10 digits are what is used for the selective routing. E911 relational database scheme. There are several databases required to make the 911 call work as well as it's supposed to. When you are thinking about, if you have a question on databases or what the particular database is, pull out the pieces of the word and think about what it is that they are describing. I think sometimes we look at the word and we think and we move too quick. Simply put, it is the building of relationships that allows the MSAG, Annie, and Allie all to interact and function together. They are all part of the process and they are all necessary to make sure that the call gets to where it's supposed to be and the information that is being delivered is supposed to be delivered and it is validated through the MSAG. Another part of the information systems is our GIS, Geographic Information Systems. It is a system for capturing, storing, displaying, analyzing, and managing data associated attributes that are spatially, I don't know how you say it, I say spatially, referenced. So spatial, meaning a place with an identifiable location indication. We're going to talk about latitude and longitude because I know that there are a few questions on the exam. And I will tell you, and I will remind you, if you haven't heard me say it before, I am geographically challenged. I am not good with directions. If you give me directions, don't use words like east and west. I joke in all my classes that I just found out that Alaska is not an island near Hawaii because that's where they put it on the map. But at the end of the day, knowing as much as you can about latitude and longitude is going to help you process the call. I don't think in basic 911 telecommunicator training, we spend enough time on latitude and longitude. And I had to put a lot of work into remembering all these little nuances about latitude and longitude. So I'm going to share them with you. You may know what's what direction, what letter, what sign, plus, minus, whatever. But if you don't, here's your tutorial. First, latitude. Latitude runs east and west. Okay, I could say west and east, but that's not how we say it, right? It runs east and west. It is represented by the letter Y. Longitude runs north and south. It is represented by the letter X. Now, for the life of me, I could not remember which one was Y and which one was X. So I'm going to fill you in on a couple of Tracyisms. Number one, the way that you are supposed to say latitude and longitude is just like that. Latitude and longitude, not longitude and latitude. So how do we remember which way to say them? Alphabetical order. LA versus LO. Latitude and longitude. Latitude is supposed to come first. Does it always come first? No. Does everybody know the rules? No. But consistently, generally speaking, it's usually latitude, longitude. Lat long. Okay. So if we go consistently with lat long being first, the words are in alphabetical order, but the letters are not. So think about what I just said. Lat long. Okay. LA is in alphabetical order, but the Y comes after the X. So when I stop and think, I will say lat long, the letters are in order, but they're not, and it's X, Y. Okay, that's how my brain works. Maybe this helps you, maybe it doesn't. Justin just added, I remember latitude is this way. Lay is latitude, lays flat, and is the Y. That's a great way to remember it too. And a couple of folks are going to add their ways of remembering. By all means, add them. Maybe you take it with you. And so the LA of latitude. Yep. All right. I like that. And again, I'm going to give you a couple of ways to remember these things. Whatever you do to remember it, just remember it, because I know there are questions about latitude and longitude on the exam. And if you can get this down, that's a couple of questions that you're just going to get right. Okay. And it's relatively easy to learn if you put the time in and figure out these weird things. So latitude, longitude comes first. This is going to come up another place as well. The other way to remember which ways they run is using a ladder. So if I think of the word latitude, I think of ladder, right? So latitude, that's how I talk. Latitude. When you think of a ladder, the first thing I'm going to think of is, if I say the word ladder, I'm going to think of rungs of the ladder. The rungs on the ladder, they go this way. And then longitude, the sides of the ladder are much longer. And so longitude and the long sides of the ladder, they run north to south. So take that for what it's worth, knowing which direction the lines actually go. Now, which one is plus or minus? This, I don't have a ton of tips to help you remember. maybe positive always comes first. We always want to be positive, right? And so when we think about how we should be putting latitude and longitude in order, again, it's supposed to be the plus first and then the minus. And how do we remember the plus or the minus, which one it goes with? So when we describe things, we say plus or minus 5 miles. We don't usually say minus or plus 5 miles. So the plus is going to come first. Latitude comes first. That's a way to remember. But I just want to show you where it comes from. And this is going to be relevant to how you're adding the latitude and longitude into anything that is going to turn it into something else. So positive latitudes are north of the equator. So we have the equator right here. All right, so this little arrow, this is where we are. So in the United States of America, this is how we are rolling when it comes to putting latitude and longitude into anything to give us, say, a reverse geocoded address or an identifiable location. So positive latitudes are north of the equator. So anything that is up here to the north is going to be a positive to start off with. Negative latitudes are south of the equator. On the minus side, we're going to look at the meridian, okay? So where we separate the Earth here in the middle. Positive longitudes are to the east of the meridian, and negative longitudes are to the west of the prime meridian. So here we are, we're positive because we're to the north of the equator, and the longitudes are negative because they are to the west of the prime meridian. And then latitude and longitude are generally expressed in the sequence latitude before longitude, as I mentioned. So latitude is plus, longitude is minus. So if you are entering that into Google Maps and such, you need to put it in the order in which it's intended. Latitude first, longitude second. Otherwise, you're going to end up in Antarctica somewhere. Okay. So latitude plus, longitude minus. So why does it matter? I'm going to show you. I'm going to use this particular alley for something else when we talk about femtocells. That's why I actually have this, because it lists femtocell on here. But what I also want to show you is, not sure whose phone system this is, but look at the way they entered the coordinates. If I don't know how coordinates go into any type of searchable thing like Google Maps, then I'm going to put them in incorrectly. So looking at this plus, I know that the plus is supposed to come first. I know that the plus is the latitude. So if whatever I'm putting them into says latitude, I need to go for the plus. And if it says longitude, I need to go for the minus. That's what it's going to be in the US. In this particular case, they had it backwards. So if I just picked up these numbers, if I copied and pasted these numbers, it would not give me a valid location. So I'm not sure why they display it like that, but nonetheless, that's an example. And could that be a problem when we're trying to find a location? Sure can. So there you go. Global Navigation Satellite Systems, GNSS, is a network of satellites, broadcast timing, and orbital information used for navigation and positioning measurements. There is approximately 30 satellites out there in orbit, bouncing around. And this is how we get GPS. GPS is one of the global navigation satellite systems, GNSS, that provides latitude, longitude, altitude, course, and speed. This is how Google Maps knows where I'm going and how fast it's going to take me to get there. The constellation, there's approximately 30 of these satellites orbiting the Earth at any given time, but there are at least 4 that are visible from the Earth at all times. The more visible satellites that a device can see, the more precise the location information is going to be. Assisted GPS, AGPS, is handset-based location determination method that is used in wireless networks today to acquire the location of a 911 caller. That's some of the stuff that we used at Rapid SOS. It uses data connections to connect to the assistant server in the network of the satellite information. The assistance data provides a faster first fix than a standalone GPS, and it requires a special chip in the handset to be able to do that. We have geocoding and reverse geocoding when it comes to GPS and our location information. Geocoding is the process of taking an address and returning an actual or calculated latitude and longitude coordinate. So if I put in 123 Main Street, it's going to give me geocoding is going to give me a latitude and longitude. Reverse geocoding is the process of converting the coordinates into an actual calculated civic address. The problem with reverse geocoding, it is not always accurate. Again, I'm going to show you an example of that when we talk about the femtocell thing. We put a lot of value on reverse geocoded addresses that are tapping into a database that pops up on our 911 system that is providing an address for us, when in actuality, it might not be the exact address. We just take it at face value. We give it out to our responders. In a couple of my classes, I spend a lot of time talking, not a lot of the time, but I spend a decent amount of time talking about the importance of really looking at your mapping. Like truly looking at your mapping, and you'll see an example of that when I talk about the femtocells. For more information on cellular wireless location determination, your study guide recommends this particular document right here. As mentioned before, while in most of the links that I provide in the PDF, you can just click on it. If it is one of these longer ones and the Chrome and the hyphen is on above it, you need to copy and paste the entire address. You can't just click on that one. It's got to be one continuous thing for you to be able to click on it. And for whatever reason, I'd make it too small and for it to be all one thing. So just go ahead and click on that. Copy. We have third-party databases that are part of our next generation 911 world. A third-party database is one that's considered a third-party database is the NINA's Enhanced PSAP Registry and Census, the EPRC. And I've said this before in a different place. If you have not requested access to this free tool, you are behind the 8 ball. The amount of information that is available here is very beneficial to the job that you do. It'll tell you what address is in what jurisdiction and what PSAP goes for it. If I say I'm at 123 Main Street in Rochester, Mass, and for whatever reason my call went to Rochester, New Hampshire, and they don't know the phone number of Rochester, Mass to be able to transfer that call to, the EPRC can do that. If I say I'm at 123 Main Street in Rochester, Mass, you can go right up to this top box here, type in 123 Main Street, Rochester, Mass, and the information for the PSAP is going to come up. And that includes a 24/7 number that the calls can be transferred to. So if you have any questions, just Google the EPRC, NINA EPRC, and you can go there and it tells you how to request access to this very beneficial tool. The NIEM, I know this is on the exam, or I don't know that it's on there. I know that it has been on there in the past. It was on mine. I do have some folks that will list it as something that I don't go over, but I do. It's been here since day one. It's just one of those things. If you don't put the time into studying it, then you may not remember that I mentioned it. So basically, what the National Information Exchange Model is, the NIEM, it's a common vocabulary that enables efficient information exchange across diverse public and private organizations. So basically, it takes like information that is just named something different and it names it one thing. So if organization B or A calls the last name a last name, organization B in their field, they call it a surname, an organization C in their organization, they call it a family name. What the NIEM does is it creates one title for all of those things. So as you can see in the NIEM, it says person, surname. Okay, so last name, surname, and family name will all be translated and put into one format. NINA is working towards making their data structure accommodate the NIEM format. The vision is to be the best practice by choice for intergovernmental information exchange. And if you want more information on that, NIEM.gov. Number Portability Administration Center. It is basically exactly what I just said. It's moving phone numbers, creating more places and ways that numbers can be in one place versus another. So the Number Portability Administration Center is a function of the Federal Communications Commission. It's a data administration, and they work to port telephone numbers, and they basically ported telephone number data administration, service provided data network administration, and audit administration. There are mass changes that happen here, such as area code splits, and we've talked about this before. An area code split is when we need to create another area code for a particular jurisdiction because we have run out of numbers. And then billing and cost appointments also happen here. The National Forest Guide, we're going to talk about when we talk about the NG 911 stuff. It is better suited over there. The PSAP Credentialing Authority, the PCA, is a function of I3, NINA I3, which we'll talk about with our NG stuff, that serves as a top-level certificate authority for NextGen 911. They are the root authority designated to issue and revoke security credentials to authorize 911 agencies in an I3 compliant infrastructure. Throughout prevailing standards for NG 911 credentials used for NG 911 must be traceable to the PCA. In other words, it's a stamp of approval, making sure that each agency is following standards that have been put in place to accommodate the next generation 911 purposes. Relational databases. Okay, so different types of databases. Interfacing data streams are two different types of relational databases. So interfacing in the context of relational databases refers to the interaction and communication between different software applications or systems. It involves the exchange of data and functionality to ensure seamless integration between components of the NextGen 911 system. Data stream, as it pertains to relational databases, is a continuous flow of data transmitted or received in real time. In relational databases, data streams are used for the efficient and timely transfer of information between various components of the NG91 system. So what does that mean? In other words, interfacing is the well-connected road network facilitating communication between different parts of the NG911 city, and data streams are like the flowing traffic that ensures that the information moves efficiently. So the interfacing is kind of the roadmap, and the data stream is the cars that drive on the roads. E911 record creation. It's the chart. So the chart on the next page is going to illustrate how the database interacts to create E911 records. So when it comes to how we create the records, there's initial creation, there's updates, etc. So if we're going to create it initially, there has to be a provider service order to say, hey, here is a new record that needs to be entered. And then it's going to follow this particular process. There's more that description of it in your study guide. You're not going to be tested on how it is created, but just know that there is a process for the E911 record creation. The location of our databases, they are in a couple of different locations. There's centralized alley within the network that is managed by the system service provider. And then there's on-premise alley at the PSAP level that is usually managed by the PSAP or an E911 service provider, depending on how your system is set up. And then database development and implementation maintenance. So database development, implementation, and maintenance phases. I don't recall this particular process being on my exam, and I don't know if you will see it, but logically, if you have to put them in order, if you have to determine what comes next, it's pretty logical. So imagine if we created Camelot, a new area, didn't exist before. We have just separated this jurisdiction over here, and we're starting from the beginning. So first we have to establish the emergency zone definition. What are the boundaries of this new place going to be? Phase 2 is initial MSAG creation and validation process. So we got to figure out what the roads are. We got to name all the roads, which roads are going to go where, how, what are the numbering sequences, etc. We have to check those. Simulation and discrepancy process, make sure there's no mistakes, and then finalize the MSAG and establish an ongoing process. Anytime once we've established that process, if we need to have any types of updates, that's what's going to come next. Load error correction. So we're going to test it out. We're going to make sure that everything is compatible, and then we're going to fix everything at once. And then it's going to be daily batch updates after that. And then system training, testing, and public cutover. The location of our E911 databases, they're in a few different locations. It can be located at the telco itself, at a self-maintained at the PSAP physically. It could be a standalone at the PSAP via the telco. So the telco is maintaining it, but it's physically located in the center, or individual provided and maintained. And then I think this is going to be the last section. maybe not. We may go over just a few minutes today because I want to make sure that we get everything that's on this particular session on this particular recording. So there are non-voice communications. First and foremost, telematics. Okay. So telematics involves the integration of telecommunications and information technology to transmit real-time data related to our vehicles. In emergency services, telematics can provide valuable information about a vehicle's location, the status of the vehicle, the condition of the vehicle, and sometimes the information of the occupants in the vehicle. So telematics is the vehicle. Telemetry is sending of that data through that process. So telematics, the mechanisms that support the acquisition of telemetry data and the action based upon it. Telemetry is the technology that allows the remote measurement and reporting of information of interest to a system designer. So when we think of telemetry, the first thing I think of is Johnny Gage on the front lawn of somebody's driveway, front lawn of somebody's house, sending valuable information to Rampart. Why is performance management so important? Oh, sorry about that. That slide was not where it was supposed to be. Text messaging, another non-voice communication. Text messaging is a short message service, SMS. NG911 in its final state supports text to 911, but it requires NENA I3 emergency services IP network, ESINet, and connected PSAPs that are capable of receiving IP-based signaling and media. The majority of our systems are still accepting text message through over-the-top solutions. The goal is to get it onto the ESINet and have it come directly into our call handling solutions. While the transition to NG911 is making progress, there is a push to enable text to 911 before NG911. The SMS interim text messaging is a temporary solution to allow text to 911 in their communities before an I3 ESINet IP phone system is enabled. That's that over-the-top solution. The session can be initiated when the caller uses the signal code 911 to text 911. The texter will receive a bounce back if the area does not accept text to 911. And then photos and videos are not accepted yet via text 911, which is good, right? A text control center, a TCC, was introduced to support the interim text to 911 solution. The TCC interfaces between the text user's carrier and the PSAP. Text messages are sent to 911, sent to a 911 route to a TCC that queries the location server in the originating wireless network. What I can tell you is that location is not great. That location is a different location than what we get from our wireless 911 calls. That is why I always recommend using the Rapid SOS portal, because it shows the exact location based on the operating system, not based on the location that the TCC is requesting from the network. There are 3 ways the non-I3 PSAP can receive the delivered text message. I3 IP through a TTY TDD gateway, or over the top through a web service web portal. And that's how most folks are getting it today. We have real-time text, RTT. So in 2016, the FCC adopted a report and order that amended rules to allow IP-based wireless carriers to provide RTT instead of TTY. Now we're not fully getting away from TTY, but this is This is kind of the goal, right? So moving towards real-time text messaging. It allows the consumer to send and receive text characters and other simultaneous data as they are typed. The availability of information at the exact time that it is occurring. The abilities, the PSAP's ability to receive real-time text 911 will vary depending on each of the agency's technology capabilities. Not all agencies can receive it, but once they are able to receive it, then they need to submit a request to the carriers, just like we did with wireless, to say, hey, we are ready to receive the real-time text information. Go ahead and send it through. Multimedia is a form of communication that combines different content forms such as text, audio, images, animations, videos in a single presentation, in contrast to traditional mass media such as printed material or audio recordings. Email, I don't think I need to explain what email is, but it is messages that are distributed by electronic means from one computer to another or more recipients via a network. Social media networking, I don't think I need to explain what this is. You'll be able to figure out what that definition is. And the same with device applications. I am going to finish up with this section here, information networks and security stuff. So as far as our information networks go, we have internet and intranet. Inter is a network comprised private, public, academic, business, and government networks of local to global scope, linked by a broad array of electronic, wireless, and optical network technologies. That's the internet. We know what the internet is. Intranet is a local or restricted communication network, especially a private network created using a particular software. So go back to the inter versus intra. Intra, rah, they're in our group, right? So intranet is just between our work, my company, etc. As far as information networks go, we have 3 different types of networks. We have a local area network, which is a transmission network that encompasses a limited area. It's local, it's just to our area, such as a single building or several buildings that are nearby each other. We have wide area networks. It's a computer network that spans a relatively large geographical area and consists of 2 or more interconnected local area networks. And then a wireless local area network, which is a network that allows devices to connect and communicate wirelessly. So local area network could be my town hall facility. All of the computers are on a local area network. A wide area network, we can now branch out and add the police department, the fire department, the highway department onto that WAN. And then a wireless network could be connecting the police cars, ambulances, etc., where they are not stationary, they are actually mobile. There are 4 different securities that they want you to be aware of: physical security, cyber, network, and personal. So physical is the security of the protection of our personnel, our hardware, our software, our networks, and data from physical actions and events that could cause serious loss or damage. So bulletproof glass in your lobby, etc. Cybersecurity is going to protect our networks from any type of cyber threat. Our network security encompasses that the network integrity is good as far as the next generation 911 infrastructure goes. And then personal security involves policies and procedure to ensure personnel security, personnel security is to assure that the right people are in the proximity to the things that we have access to. So making sure that people are CJIS certified, doing background checks and fingerprints, etc. So those are the four types of security that they are wanting us to know about. Without security in place, we could be putting ourselves in a position to experience a denial of service attack, a DOS attack, DOS attack, which is a type of cyber attack intended to overwhelm the resources of the target PSAP and deny the ability of legitimate users of the target to use normal services, the normal service that the target provides. Lawrence County, Tennessee, almost a denial of service. They worked very quickly to get their system shut down so they didn't lose everything. If you want to hear a great podcast on what happened that day, go to the On Scene First with Tracy Eldridge Webb's podcast, episode 27 with Marty Crum. He talks about how he got a notification that all of these little lock screens came up here, and folks had hacked into their system and were going to take them down. A lot of valuable information shared in that podcast. A telephone denial of service, a TDOS attack, is a form of denial of service directed at a telephony interface that generates numerous phone calls, tying up the network and preventing the destination from receiving legitimate phone calls. We've had a couple of these, unfortunately. Occasionally, the T and TDOS is for telephone or telecommunications. But if you want to read or watch an interesting video, that happened to the folks in Gardner, Massachusetts. I have this link here where the IRS scammers were scamming people in their jurisdiction. One of the folks that got scammed notified the police department. The scammer then called the police department to get information that was provided from the person they were scamming. And when it was not given over to them, they were able to obtain all their phone numbers in and out of the building, and they robo-dialed them. It lasted for about an hour, I think, and this is what is considered a TDOS attack. Then there is what is called a distributed denial of service, a DDoS attack, is when more than one, often thousands of unique IP addresses are attacked. And they are attacked with things called phishing. They can get into your networks in your system, and they are also often a result of multiple comprised systems. For example, a botnet that is infiltrating the networks, locking things down, and making them inaccessible. So there is that. All right. So with that, we got right to 4:30 today. I want to thank you for joining me. Again, I'll be getting you some recorded information over the next week. And if you're looking for anything fun, check out the On Scene First store there. We got stickers, shirts, challenge coins. We'll be adding some more things in the very near future, especially for Telecommunicator Week. And if you should need to get in touch with me, there is the QR code for a quick contact form. My email address, tlridge@onscenefirst.com. If you are looking for some support on Facebook, check out the On Scene First Safety Net group, First Responder Wellness group. Just add what agency you're with so I don't have to go searching for you. And until next time, heroes, stay safe, stay strong, and stay here. We need you. Thank you.